this video, we will take a look at how to design and analyze analog as well as digital communication link using OptSim. This is the schematic for analog transmission over an optical fiber. So here in the transmitter section, you have a 1 GHz carrier which is amplitude modulated by a 0.01 GHz signal. You can find the components that is used in this particular schematic from all models, sample mode models. Go to the electrical sources. There you can find a sinusoidal wave signal generator. So drag and drop two such models into the design area. Under optical sources, you can find the CW laser source. Under optical modulators, you can find the sine square amplitude modulator. Under optical amplifiers, you can find the fixed output power amplifier. Under the electrical components, you can find the multiplier model. If you go to the split and combine option, there you can find the optical splitter. You can find the optical fiber under the fibers. Photodetectors, there you can find the pin photodiode. And the electrical filter can be found under the electrical filter section. So here we are using a low pass filter, so you can find a 2-pole low pass filter. Rest of the measurement components you can see under the measurement components. You can find the electrical and optical scope as well as a spectrum generator. So from this particular measurement component section, so you can drag and drop the components into the design area, make connections as you can see in the schematic. In the transmitter section, here you have a 1 GHz carrier which is amplitude modulated by a 0.01 GHz signal. So if you just go to the properties of this particular signal generator, you can see that the signal frequency is set to 0.01 GHz. And for the second analog signal, the property is set as 1 GHz, which is the carrier frequency. And both these analog signals are multiplexed together and fed to the electrical input of the modulator. And you have a CW laser source with a sender emission frequency of 193.1 terahertz, and the CW power is taken as 5 dBm. The laser output is connected to the optical input of the modulator, and then a booster is connected. If you go to the properties of the booster, there you can see that output power is set to 6 dBm and the gain shape is chosen as flat. The fiber is a single span fiber which consists of a 50 km DS normal fiber. So if you just go to the properties, and if you see that we have chosen a DS normal fiber, this is one of the commercially available fiber in OptSim. For that you can just click on to this option, and here you can find the number of different commercially available fibers that you can use in your design. So we are using the DS normal in this case, so choose the DS normal and you can click onto the load button. Once you load the fiber, all the parameters of this particular commercially available fiber will be added to all these property tabs except for the length. You can adjust the length of the fiber as per your requirement. In this case, we are going to use a fiber of length of 50 km. Click on apply OK. So just after the fiber, we are using an inline EDFA. This is basically for the loss compensation. If you go to the properties, you can see that output power is taken as 6. And at the receiver, we are using a pin photodetector. Set the reference frequency. You can adjust different parameters like the quantum efficiency, the responsivity, etc. based on your application. You can see that in the receiver section an AM demodulator is implemented. For that we are using a electrical signal multiplier. So one input to the electrical signal multiplier is the output from the pin diode. Other input is the 1 GHz carrier signal. The output of the multiplier is connected to a low pass filter whose properties you can set from this particular property tab. So here we are using a 2-pole low pass filter with a frequency of 0.01 GHz. We are filtering this particular frequency. Once the connections are made and properties are set, you can run the simulation. So to run the simulation, you can click on to the go button. Start single run. Let us take a look at the amplitude modulated signal, for which you can open the result of the scope 1, view electrical signal. So here you can see the amplitude modulated signal. If you want to take a closer look at the signal, you can just left click the mouse in the display area, and you can just select the area where you want to take a closer look. Likewise, you can analyze the signal. Now let us take a look at the received signal. So you can just go to the scope 2 and view the electrical signal. So here you can see the received signal. You can also compare the transmitted modulated signal with that of the detected signal. This is how you implement an analog communication link using OptSim. Now let us take a look at how to design and analyze a digital communication link. So this is a schematic of a digital communication link. The components or the models that is used in this particular schematic can be taken from the Explorer section, all models, sample mode models. The transmitter section consists of a data source, an NRZ driver, a CW laser, a modulator and a booster. You can find that components here. So if you go to the logical sources, there you can find the data source. You can go to the modulator driver section, and there you can find the NRZ rectangular driver. Under optical sources, you can find the CW laser source, and under optical modulators, you can find the sine square amplitude modulator. If you go to the optical amplifier, which is a fixed output power amplifier, you can get the optical fiber from the fiber section. You can find the optical filters that is used from the optical filter section. So you can find the raised cosine optical filter here. If you go to the electrical filters, there you can find the Bessel electrical filter. Under optical components, you can find the optical attenuator. Under split and combine, you can find the optical splitter. Find all the measurement components used under the measurement components section. You can drag and drop these components into your design area and make connections as shown in the schematic. So here in the transmitter section, you can see that we have a 9.953 gigabits per second digital source and an NRZ modulator driver. We are using an external sine square amplitude modulator. We have a CW laser source at 193.1 center frequency. CW power is taken as 5 dBm, and we have a booster with an output power of 6 dBm. Here the optical link consists of two spans of fiber, as you can see here. We are going to use a 50 kilometer DS normal fiber, which is a commercially available fiber, and then we are also using inline EDFA for the loss compensation from the fiber. So if you just go to the properties of the fiber, you can set the fiber as DS normal from this list. Click on load button, and then you can set the length. So here we are going to choose 50 kilometer for both the fiber. Here if you just go to the properties of the optical filter, you can see that it is a bandpass filter, and you can enter the corresponding values here. So here the -3 dB bandwidth is taken as 60 GHz, center frequency is taken as 193.1, which is followed by an attenuator with an attenuation factor of 25 dB. We have a sensitivity receiver. The unfiltered output of the sensitivity receiver is connected to a Bessel filter. So if you just go to the properties of the filter, it is a low pass filter with the number of poles set to 5 with -3 dB bandwidth as 8 GHz. And then we have added some measurement components to view the results. Once the connections are made and properties are set, you can just click onto the go button to run the simulation and click on start single run. Once the simulation is complete, you can view the received signal as well as the output spectrum.